Hey everybody, welcome back to the Routing Loop. My name is James Wenzel. Everybody calls me Jamie, and it's good to see all of you here. And I am joined by my good friend Ankit, who has been on the show a few times before. Say hello, Ankit.
Hey folks,
He
how's
does.
it going?
He exists. He's not a bot, I promise. So just to talk about a little bit of what we do here for the Routing Loop, we are talking about building networks, scaling networks, everything there is to do about networks on AWS and the AWS platform. And Kit, you want to tell us a little bit about yourself, who you are? I know you've been on the show a few times, but we've got some new viewers. Hello, hirings.
Yeah, absolutely. Hey everyone, my name's Ankit. I'm a networking specialist solutions architect at AWS. And in my current position, I support what we call global customers or AWS industries customers. So these customers generally tend to have larger deployments. Think something like multiple data centers deployed globally, multi-region AWS deployments, and many tens, hundreds, sometimes even thousands of branch locations as well. So the architectures tend to be pretty interesting when it comes to end-to-end operations, routing, and debugging.
Yeah, so just to kind of put it in a different way, there's a good chance that something that you use daily has something to do with a network architecture that Ankit has said something about, or given recommendation on, or even possibly designed. So yeah, those size customers. So Ankit, today you're talking to us about what?
So today we are going to be talking about really end-to-end connectivity for a global networking use case. So we'll start off with um, a pretty simple direct connect based use case for connecting AWS to a data center. Then we'll branch out into connecting branch locations, how you would connect, let's say, a 1Z2Z branch location. And then just in case your deployment grows or your requirement grows, what are the considerations for you to think about using something like SD-WAN vendor? And if you already use an SD-WAN vendor, what are the options for integrating that SD-WAN topology into your existing or new AWS network?
Now, why would you want to use an existing SD-WAN vendor versus like building something new? Because some networking folks are always of the opinion that new is better. Can you give us some ideas of why you would pick to integrate
Yeah,
what we got versus?
yeah, sure thing. So there's various options. Um, where I see customers using SD-WAN is, breaking the reliance from, let's say, private MPLS backbones for connecting various branch offices. So what SD-WAN gives you is the capability to connect or orchestrate connectivity and simplify operations by connecting those branch offices to each other and to resources over the internet most of the times. So when somebody already has a mature SD-WAN deployment, perhaps the easiest way to success for an end-to-end connectivity is to integrate that existing deployment that you have with an AWS cloud deployment.
Perfect, perfect. So, what did you got to show us?
So as always, we are all network folks. So I'm going to share my screen. Let me know when my desktop or my whiteboard or my OmniGraffle screen is up.
It's up.
Awesome. So I know it's OmniGraffle, but I promise I'm not completely stuck in the 90s, folks. If anybody else uses OmniGraffle, please give me a shout out. So what I'm showing on the screen is one data center, one corporate data center that may exist somewhere. And as customers deploy their workloads into AWS, they would perhaps choose a region. They would deploy their workloads inside of a VPC or a virtual private cloud. And then to connect these VPCs to each other at scale, many customers often use services like Transit Gateway or Cloud WAN to provide this VPC to VPC connectivity. Now, at this point in time, a question opens up, which is how to connect the data centers back into AWS. So that's where one of the options is to use a direct connect. A direct connect is basically a private circuit that gives you private connectivity into AWS. So you would work with a partner or an ISP to extend connectivity into an AWS Direct Connect location. And then you can use a globally distributed resource like um, a direct connect gateway, which is a lot like a route reflector or a distributed route reflector, and then spin a transit WIF or a virtual interface that is essentially a BGP peering and a VLAN under the hood. And this transit WIF can hook up into or get associated with either Cloud WAN or transit gateway. So once a deployment like this is set up, you basically have connectivity between VPCs through transit gateway or Cloud WAN, and then between VPCs or AWS and on-prem deployments. So this is again a very, very simplified way of showing how you would connect your on-prem data centers into AWS. Let me pause there in case there are any questions. I actually cannot see the comment window.
No, you're pretty good. But what different types are there for Direct Connect? Is it just one offering, or do we have different flavors, if you will? Can you give us a color of the sizes?
Yeah. So basically, at the connection level, you can have either a dedicated connection, which means the entire connection, whether it's 1 gig, 10 gig, 100 gig, it's dedicated to you. It's not shared with anybody else. And then there is hosted connections. With hosted connections, you basically get one VLAN and one BGP peering. And under the hood, that is a slice of a bigger interface or a full physical interface that is shared across multiple customers. So to get a hosted connection, you would likely work with a partner. And when you have a dedicated connection, the entire connection is exclusively for you. So the benefits would be with a dedicated connection, you could have multiple VLANs and multiple BGP peerings, whereas with hosted, you get only one.
We do have a question from Dominic, longtime friend of the show. What if we cannot get Direct Connect service in our location? What are their options?
Yeah, you could use an IPsec VPN over the internet as well. And that's something that we'll start talking about as we start thinking about, let's say, connecting a branch office or connecting smaller locations or connecting locations where direct connect is simply not available.
Now, there's one other thing too, depending on how you're distributed and in terms of an organization globally, but you could always offer or get Direct Connect in a location that is available that you also have some sort of physical location in, and then use Direct Connect Gateway, which is a global construct. You will pay some cross-region charges for this, but the Direct Connect Gateway can connect up to any other region outside of the one that the Direct Connect was put in as well.
Yep.
Just kind of throw that out there.
Yep, absolutely. So I didn't get that question properly, then my bad. Yes, overall, this Direct Connect Gateway, globally distributed resource, and this can, the southward connectivity that I'm showing, it can be in any AWS region, or sorry, in any Direct Connect location. So basically, you come into a Direct Connect gateway, and then the Direct Connect gateway will get associated into your transit gateway or Cloud WAN. Now, there is one interesting thing out here. Just to save real estate, I showed only one connection, but I wanted to talk a little bit about Direct Connect resiliency. So there are various models of Direct Connect, and to get maximum resiliency, our recommendation is to basically have 4 Direct Connect circuits with 2 Direct Connect circuits each in 2 Direct Connect locations. So it would be a lot like this. You would have 2 different Direct Connect locations, and then you would have 2 circuits in each of the locations. So once you make the investment in the physical infrastructure to get maximum resiliency, after that, you're still required to send the same prefix to AWS over all these 4 connections or over 4 different WIFs, so that you get the physical redundancy and logical redundancy at the same time. So just wanted to highlight that, as it tends to be a frequently asked question with customers when it comes to Direct Connect resiliency.
Perfect. Yeah, and I also put up the document that we have about getting an SLA for Direct Connect. So if you do look at wanting to have a resilient setup, you need to make sure that you follow all of the guidelines within the SLA. Being able to fail over between them, just because you have a couple of extra ports doesn't necessarily mean that you get an SLA. So you can reference that in the chat.
Yep, absolutely. Awesome. So let's grow this use case a little bit and let's start talking about branch locations. So in this case, I'm showing only 4 small branch locations, but the concepts that we'll discuss, they apply to, let's say, hundreds or maybe even thousands of branch locations as well. So before SD-WAN came along, or before AWS integration with SD-WAN came along, some of the options for connecting these branch locations back into AWS were using something like a site-to-site VPN or an IPsec VPN between AWS, which would be Transit Gateway or Cloud WAN, and then the other end would terminate directly with branch offices. So this model works. It's fully supported. The only consideration over there would be firstly the bandwidth. Each IPsec tunnel can do 1.25 Gbps, and then secondly, the scale or the total number of IPsec tunnels that you can have per region is pretty limited. So as your deployment grows, that's where again the SD-WAN conversation starts. So what I'm showing out on the screen is these couple of routers or the SD-WAN hidden routers. One example is in AWS, and the other example is when the SD-WAN hidden router or the SD-WAN concentrator is sitting on-prem. And all these green connections are basically tunnels that are orchestrated by the SD-WAN vendor or the controller between spokes and the hub. So for the rest of this presentation, we'll basically consider anything in bright green as a tunnel, most likely IPsec tunnel, that is created, managed, and orchestrated by this SD-WAN provider. Now, with this deployment, as you can imagine, providing connectivity to and from branches is carried out in like a hub and spoke model, where the spoke are the branches and the hub are the SD-WAN hidden routers. And this again opens up the question as to how do we integrate this back to an AWS deployment. For example, if you have transit gateways, regional transit gateways, or a global cloud WAN deployment. So over here, again, one of the I want to say um, legacy options that exist are to just create an IPsec tunnel between this hidden router and, let's say, transit gateway, and then do BGP over IPsec and exchange routes. So again, that is also a supported option. But again, the consideration over there would be scale, both in terms of bandwidth and the total number of tunnels that you would have. The total number of tunnels comes into the picture because each tunnel will give you 1.25 Gbps. And in case you want to increase your bandwidth, you would basically spin more and more tunnels and then ECMP across them. So to solve this problem of scale, now we'll start heading into the SD-WAN integration with AWS, which is basically a connect attachment. And one more thing, folks, um, we'll also have a demo in the middle of the session or towards the end of the session. While Connect is supported with both Cloud WAN and Transit Gateway, in today's demo, we'll focus specifically on the Transit Gateway. Any questions, Jamie, before we start diving into the Connect attachment as well?
Oh, just one thing I want to just clear up with ECMP, equal cost multipath. You will get that on the transit gateway, as in Kit mentioned. You will not get that on the VPCs, though. Even though you can land your direct connect onto a VPC's VGW, still says the 1.25. They are 2 tunnels, but only one is active at a given time. I think they're both active. Just correct me if I'm wrong on Kit, but they're both active on receiving traffic from AWS, but only one is active in pushing the traffic to AWS. So for true ECMP, getting up to 50 gigs available, you need to do that on the Transit Gateway. But regardless, we're doing the Transit Gateway Connect as well. So that's a 5 gig tunnel. We can, I'm sure Kit's going to show you more about that. But that's pretty much it from my side.
Awesome. Yep, good call out, Jamie, there. The bandwidth and the ECMP, ECMP specifically, the rule of thumb would be use a transit gateway or cloud WAN, again, if you're headed into the ECMP territory. With VPC, like you said, ECMP is supported, but only in one direction, so it becomes complicated. Awesome. So let's start going into the SD-WAN integration. So basically, there are 2 flavors. If we go back to the previous drawing, um, some customers prefer to deploy their SD-WAN routers inside of AWS to leverage the benefits of pay-as-you-go model. And some customers prefer to have hardware SD-WAN hidden routers that are deployed either in data centers or sometimes even in colos like Equinix, etc. So our AWS's Connect attachment basically supports both the models. So this first model is when the Connect attachment or the SD-WAN integration is done, when the SD-WAN hidden router is deployed inside a VPC inside AWS. So the first thing to consider here is that these resources on the left hand side, Cloud WAN or Transit Gateway, they would create this Connect attachment going towards this VPC. And this Connect attachment would ride on top of the underlying VPC attachment that exists between the Transit Gateway and this VPC. So the key takeaway over there is just like you would associate your workload VPCs with Transit Gateway as a VPC attachment, the first step to getting a Connect attachment is to create a VPC attachment towards your SD-WAN VPC as well. Now, once this Connect attachment is created, um, um, to get dynamic routing, you would configure BGP over GRE between this EC2 based virtual router appliance and either Transit Gateway or Cloud WAN. Now, this same model is supported when you have a transit WIF or when your um, a hidden router is sitting on prem. Uh, in this case, the transport would be a direct connect gateway association between the transit gateway or Cloud WAN. And net at the end of the day, you would again get BGP over GRE that will allow you to exchange dynamic routes between this hidden router and your regionally distributed router like Transit Gateway. When it comes to limits, from Transit Gateway going towards the SD-WAN hidden routers, out of the box, you get 5,000 routes. And when it comes to receiving routes, you get 1,000 routes. So this is actually an interesting thing to consider because some of my customers have deployed this specific model, which is Transit Gateway, Connect over Direct Connect as the transport, just to make sure that they can circumvent the route limits that Direct Connect imposes. I think the default Direct Connect route limits are like 100, if I'm not mistaken. And then with Transit Gateway Connect, you get 5,000 out of the box. Um, any questions, folks, before we start diving a little deeper into how this Connect attachment actually works and how the GRE tunnels, etc., are created?
There was one connection by hirings. I answered it in the chat, but it's good to bring it up. This is regarding the traffic flow on a VPN with active tunnels. Would you say asymmetric traffic is something we should accept or we should avoid?
Tell me a little more. How do you mean asymmetric traffic over ECMP?
So my assumption, unless hiring wants to bring it up, is you would have some traffic that would go over one tunnel and then you possibly will receive it on another, or vice versa, right? So that you're accepting something from traffic that you had originally responded in. My answer to him, just to kind of clear it up, was asymmetric traffic is not necessarily an evil thing in the cloud. But it can be turned on and off depending on your business use case or situation. I just gave the example, like if you're using something like a gateway load balancer for internal traffic outside of just VPN, you can turn it on and off with appliance mode with the transit gateway so that you take the same path for inspection as you did when you originally received it, because firewalls are overly sensitive for that. Mm-hmm. So it really comes down to your business use case. Yes, we do asymmetric trafficking because that's what we need. But when not, right, we generally tend to try to enforce as much as possible standard traditional answer requests over the same path. Yep. So it really comes down to what is needed.
Yep, absolutely. So that's actually a good call out there with respect to appliance mode. So the way I would think about it is in case there are no firewalls involved, right, and there is enough entropy in the traffic flows, in that the traffic tuples are unique enough to cause entropy and asymmetric routing, perhaps that would give you an additional bandwidth if no firewalls are required. Now, if firewalls are required, like Jamie was saying, you could, let's say this one is your firewall VPC that connects into Cloud WAN or Transit Gateway as well. So you could always enable appliance mode on this attachment. So net, you could continue using ECMP between this layer, and if and when firewalls are required that are deployed on this side, you could enable appliance mode over here. So yeah, um, I agree. Asymmetric routing, not always a bad thing. That said, I would say I see less and less cases of asymmetric routing, especially because a bunch of these virtual router appliances, they hash traffic based on a flow. So it's like flow one may be mapped to tunnel one, and flow two may be mapped to tunnel two. So that's why I said that you would need enough entropy in the flows to actually get asymmetric routing.
I would almost argue that back early in the earlier days of cloud, when we're still kind of figuring things out, and a lot of it still is, a lot of the stuff is software-defined networking, you would see a little bit more of asymmetric routing than you do today. Just because of the fact that things are kind of maturing, as well as we're moving more and more workloads onto the cloud that are, let's say, more networking focused. You know, it's not just an application focused thing anymore. So you're going to see more and more strict enforcement of direct pathing versus asymmetric, and which we do give the options for.
Yep. All right. So let's dive into the innards of this connect attachment and how the GRE tunnels, etc., are created. So for that, we are going to focus on the model where um, um, your hidden routers are deployed in AWS inside of a VPC. But again, same concept applies if your transport is direct connect or the underlays direct connect as well. All right, so let's zoom in a little bit. So over here, I'm showing your app VPC on the left-hand side and an SD-WAN VPC on the right-hand side. Then you got a transit gateway that provides connectivity to both of them. And again, meta point to remember here is you would need a regular VPC attachment going into the SD-WAN VPC as well before you create a connect attachment. Then you got your two virtual router appliances sitting in the SD-WAN VPC. Now, once you have this underlying VPC attachment, you would go into Transit Gateway and send in an API call to create a connect attachment on top of the VPC attachment. Once you get this, you would be able to create GRE tunnels between Transit Gateway and these virtual router appliances, which are the orange lines. And then you run BGP over GRE on top of that. So on the right hand side, if you have these branch offices that I'm showing as 192.168.10 and 20/24. So net at the end of the day, these virtual router appliances would learn the CIDRs of each of the branch offices over these green lines that are orchestrated by the virtual routers. And since you have BGP over GRE between Transit Gateway and the VR appliances or the virtual router appliances, you'll be able to exchange routes back and forth. So at the end of the day, your virtual router appliance will send these CIDRs 192.168.10/24 and 20/24 to Transit Gateway. Those routes will land in Transit Gateway inside the routing table where you have the attachment. And then same concept applies in the other direction also. The routing table where you create this attachment, um, it will have various other routes as well. In this case, the app VPC's route. So that's the route that this transit gateway will advertise back towards the virtual router appliances. And this end-to-end flow or this end-to-end routing exchange would allow for these branch offices to access resources deployed inside of AWS and vice versa. Now, before we head into the demo, I want to talk about uh, the
I do want to
the
highlight one thing that you just pointed out there that's pretty powerful, right? We're exchanging BGP routes through Transit Gateway Connect through a GRE tunnel to the routing tables that are on Transit Gateway. And in many cases, when you look at SD-WAN, right, where you have various satellite offices, those offices may not be on all the time. Right? It could be something like a point of sale system that you're going to go and order a burger at, or a drive-through, or something that literally goes on and off. So that's kind of pretty powerful too, to think about it, that route propagation, if you will, between the satellite offices and the primary offices will be updated whether they're available or not, or if they change, or if anything changes within the routes, any adds, moves, or changes, or any type of upgrades you might do to your satellite offices. You don't have to go through every single stitch of your infrastructure in AWS. It'll just simply learn the routes and go up. One of the reason why I'm bringing that up is, one of the feedbacks we're always getting with Transit Gateway is like, where's my dynamic routing? Well, essentially with SD-WAN, you do have the dynamic routing.
Yep. Yep. That's a solid point. So when a new branch office comes up right here, as long as this SD-WAN vendor orchestrated green lines are in place, all those routes for this new branch office will be available inside of AWS. So yes, from that perspective, it is really powerful. There is another thing that I wanted to call out here, Jamie, which is, again, if we think about a multi-region or a global deployment, right? Let's say this is your region one that we already spoke about. You replicate your entire deployment in region two. So when you have transit gateway peering, or if you have cloud WAN, you even get dynamic routing across multiple regions. This also suffices or enables various global routing use cases. So a branch office that's in, let's say, Frankfurt wants to talk to an app VPC that's deployed in US East 1, for example. And one to make all of this happen, all you need is this branch office to truly come up. And after that, this um, routing across regions or the global routing use cases sufficed as well, in that you don't need to go in and touch specific things at specific places.
Ganesh has also got a quick question. Why would I need to use SD-WAN over DX? So hopefully, if you want to clear up your message a little bit or talk about SD-WAN over DX.
Yeah. So most of my customers use Direct Connect when it comes to connecting, let's say, a high bandwidth site back into AWS. And the premise of SD-WAN basically was connecting or providing connectivity over the internet, secure connectivity over the internet for low bandwidth remote sites like branch offices. So that would be one major decision making criteria on when you would want to use an SD-WAN vendor versus when you would want to get dedicated high bandwidth, low latency connectivity over Direct Connect.
So one of the things we're not saying is we're not saying to use SD-WAN with Direct Connect or Direct Connect as the medium, where SD-WAN is typically used as a VPN medium over the internet. So just hopefully that clears some things up, Ganesh, and what we're trying to say.
Awesome. So with that, let's start going into the demo topology that you folks will see today. So we'll focus on one region, but again, the same concepts apply anywhere else as well. So the major thing to keep in mind for um, the connect attachment or integration with SD-WAN is these orange lines, which is the GRE tunnels. So these are again point-to-point tunnels between transit gateway and these virtual router appliances. To make this happen, um, you need an IP address on the transit gateway side of the house. So this is a transit gateway CIDR that you would provide on the transit gateway, either at the time of creation or sometime later. And then the destination of that GRE tunnel is going to be the IP address of the actual virtual router interface. So in this case, it's 10.101.5.227. Now, at this point in time, let me go to the console and show it to you on um, um, show it to you live as well. So can you see the console window, folks?
We see it.
Awesome. So I have two Cisco CSR instances, Cisco CSR1 and Cisco CSR2, which is in line with this topology. So CSR1, CSR2. And if I go to my transit gateway side of the house, I have three attachments in place. So I have an attachment going to the SD-WAN VPC, which is a VPC attachment. I have a VPC attachment going to the app VPC. And then I pre-created this transit gateway connect attachment. So this is a connect attachment that we got. And it rides on top of this transport attachment ID. And this transport attachment ID is the underlying VPC attachment that goes to the SD-WAN VPC. So this ends in 6002, which is the same attachment ID that you see down here. So net, what we got pre-created is this entire infrastructure along with this connect attachment. So I have one of my GRE peers up and running as well, which is router 1. Router 2 is something that we'll create live on this demo. So if I go to connect peers, this is the name of the connect peer, Cisco CSR1. And this transit gateway GRE address is 10.255.255.32. So this is taken from this specific CIDR range, 10.255.255.0/24. Then the peer GRE address is 10.101.5.227, which is the IP address allocated to the ENI of the virtual router appliance or the CSR, 10.101.5.227. Now, this is where things get interesting. So um, this is going to be BGP over GRE, and for BGP, it needs IP addressing blocks as well. So you need to provide a /29, and once you provide the configuration, including the BGP inside CIDR blocks, the ASN of the transit gateway, ASN of the CSR or the virtual router appliance, what transit gateway will give you is it will give you 3 IP addresses. It will give you 2 IP addresses that go uh, it will give you 1 IP address that goes on the virtual router appliance, and it will give you 2 IP addresses that go on transit gateway. And these are the IP addresses that you would use for BGP. So let's see how that looks
One
like.
quick thing in Kit, ASN. What is an ASN and where do I get the number from?
Oh, I see. So ASN is BGP autonomous system number. So basically an admin boundary. On the transit gateway side of the house, you would provide an ASN to the transit gateway at the time of creating it. And on the SD-WAN vendor or the virtual router appliance side of the house, that's an ASN that you can choose. So in this case, my oops, made a mistake. So my transit gateway ASN is 64512, and the BGP ASN on the virtual router side is 64520.
Yeah, just basically a way for BGP to identify all the individual links with its own number, because a lot of things can be dynamic and move around. So ASNs are done that way. You could also get an auto-assigned ASN privately on a transit gateway from AWS. And as in Kit mentioned, you can also bring a public one as well. There are times when you want to use it or not use it. I just want to make sure, because we have varying levels of expertise in our audience, that we cover all of the different pieces.
Yep, absolutely. So this is where we'll start actually looking at the console and the uh, Cisco routers as well. So can you see my terminal, folks?
We see it.
Okay, awesome. So this is the terminal window for virtual router 1 or CSR1. So we will start with looking at um, the configuration of the tunnel interfaces. So this tunnel is the GRE tunnel, or this orange link that is a point-to-point tunnel between the transit gateway and the router appliance. So over here, the IP address of the tunnel is what we got from transit gateway when we created the connect peer. It is 200.1, 169.254.200.1. The tunnel source is again the IP address that the virtual router interface, virtual router appliances interface gets, and this is from the VPC's CIDR range. And the tunnel destination is an IP address that you provided to the from the IP addressing range that you provided to the transit gateway. So 10.255.255.32. So folks, this is an interesting one. And I remember being on a debugging call with a customer like maybe a year back or something. So when it comes to routing tables, to create this tunnel, you basically need to have connectivity from this virtual router appliance back to transit gateway's CIDR range. So how you would achieve that is by putting in a static route in the subnet of this virtual router appliance that says that if you want to go to 10.255.255.0/24, go to the transit gateway attachment. So it's something that's, I'm sure it's in the documentation, but I wanted to call it out still because we are discussing the details of how to set it up. Transit gateway, of course, knows the CIDR range of 10.101 because that route is propagated into the transit gateway through the underlying VPC attachment. So this is the configuration of the tunnel, the orange line that we just saw, which is a point-to-point connection between um, the router and transit gateway. The next step is BGP. So if I look at the BGP summary stat, you would see that I have two peers. So these are the two BGP peerings that we get from transit gateway. And both of these peerings are up, and I'm receiving two routes from the transit gateway. So let's see what routes are we receiving. Show IP PGP neighbor advertised routes. Oops, received routes. Okay, I need to refresh my command line. Okay, so we are receiving these two routes from transit gateway 10.1/16, which is our application VPC, and 10.101.00/16. So this is interesting. This 10.101 is actually the CIDR range of the SD-WAN VPC in the first place. And the reason Transit Gateway is sending this route to the virtual router appliances is because this VPC CIDR, or the prefix for this VPC, is also in the Transit Gateway routing table. Now, once the routes are inside of these virtual router appliances or over here, this virtual router appliance can basically advertise those routes to the branch offices over these green lines. Or another common deployment pattern that I see is these virtual router appliances just sending a default route to the branch offices over these green tunnels. So either which way, once these routes are inside of the virtual router appliance, all those remote sites can now access AWS resources. Any questions on this, folks, before we dive into the reverse side of the traffic flow?
Everything looks good. I think everyone understands.
Awesome. So now let's go up and look at the advertised routes. So in this case, I'm saying what routes is the Cisco CSR advertising out to the transit gateway. So over here, you would see 192.168.10 and 192.168.20/24. And these are actually the branch office routes that we were talking about earlier. So net, by creating this connect attachment, your transit gateway now has visibility or routing information for all of your branch offices that may be connecting into this Cisco CSR appliance. And this back and forth route exchange is what gives you bidirectional connectivity from AWS to branch offices and vice versa. All right, we do have some time, and I think we can add the second BGP peer or the second connect peer live on the call. So for that, you would go into your transit gateway attachments first. And one of the things to keep in mind is the connect peers are tied to a connect attachment. And for each connect peer, you can get up to 5 Gbps. So from a bandwidth perspective, it's already 4 times the bandwidth of what you would get over a regular IPsec VPN tunnel. So what we are going to do in this next section is add the second BGP peer or the second CSR router as a connect peer. And then we will configure the Cisco router to make sure that BGP comes up and that we can start exchanging routes back and forth. So for that, we'll actually first go into the console here. So I'll say create connect peer. I'm going to call it Cisco CSR2. So this transit gateway GRE address is something that you can either hard code or you can get from the transit gateway CIDR range, which is this CIDR range 10.255.255.0/24. So I'm just going to leave it blank. My peer GRE address, is the IP address of this virtual router interface, virtual router appliance that is reachable from the transit gateway. So it is going to be 10.101.6.84. So let's punch that in. Now BGP inside CIDR blocks. So these are the CIDRs from which you will get IP addresses for the overlay BGP peering. So in the previous one, I used 169.254.0.0. So this time, let me actually see which one I used. Okay, I used 169.254.200.0. So let's use the next one, 254.200. It will be 8/29. And we're not doing IPv6 right now. And peer ASN is the ASN of the virtual router appliance, which is 64520. And let's create the connect peer. So the config is pending right now, but net what we have gotten is detail that will allow us to go and start configuring the router as well. So the first thing that we got is the peer GRE, the transit gateway GRE address, which is from the 10.255.255 range. So this gives us enough information to start to go into the router and start configuring the tunnel interface. So first we'll configure this orange interface, which is the point-to-point GRE tunnel between transit gateway and the router. So let me see if I can just copy paste some of this. I actually cannot. Okay. So this is my router 2. So I don't have any BGP and I don't have any tunnel interfaces. Okay, so let's start configuring it. So I create the tunnel interface and I give the tunnel interface an IP address, which is going to be 200.9. Wait, where did I give 1 and 9? Okay, so this is also something I wanted to call out, folks. So when you provide that BGP address CIDR, which is a /29, the first available IP address or the first host IP address always goes to the virtual router appliance, and then the second and the third IP address goes to the transit gateway. So just something to keep in mind, and as as you are looking at BGP peers or might simplify your day-to-day operations or debugging. Say the IP address is this 248. Tunnel source is going to be the IP address of this router interface, which is 101.6.84. And tunnel destination is going to be your transit gateway's IP address, which is this guy, 255.255.94. So this is randomly chosen by the transit gateway. All right. So now that the orange interface is up or the tunnel interface is up, the next step would be to configure this BGP peering between the virtual router appliance and the transit gateway. So again, things to keep in mind are this is going to be an eBGP peering, and then the IP addresses for this eBGP peering are going to be in the 169.254 range. So router BGP 65420. So transit gateway's IP addresses should be the second and third available IPs, which is 9 and 10. Oops, 10 should be 10 and 11. Transit gateway is 10 and 11. And the other thing to remember is, since we are going over a tunnel interface, um, this 169 IP address lives on the tunnel interface, and the actual transport is over the 10.101 range. In this case, we may need to add the multi-hop configuration as well. So I add multi-hop for both, and with this, I should have everything I need to bring up BGP. So we are in idle state right now. Hmm. While I'm working on this, Jimmy, any questions in the chat?
Yeah. Also, don't forget to write your memory. So the first question from Ganesh is just want to kind of know the advantage over SD-WAN versus site-to-site VPN. So talking just the differences of doing site-to-site VPN and SD-WAN, and why would we do one over the other? Like just conceptually, that's the first question. If you want to take that one, or I could take it.
Yeah, we can talk about that. So let's come up here, right? So um, the first thing to keep in mind would be scale in terms of the number of sites that you want to connect, right? So with IPsec VPN, I think you get 50 VPNs by default out of the box. I think that limit is increasable, but and with every tunnel you get 1.25 Gbps. With SD-WAN, there are two aspects to it. One is the SD-WAN uh, tunneling that would be between your head-end routers and the branch sites. In my experience, these generally go over the internet, and these are high volume with respect to the number of sites, like could be hundreds, could even be like thousands per region, and
Mhm.
low bandwidth, right? And now, since this becomes your concentrator for all of the SD-WAN, for all of the IPsec tunnels to the branch sites, the scale or the bandwidth scale here matters. So if you were to use um, uh, a- the connect attachment between the head end router and AWS, you can get up to 20 Gbps, whereas with whereas with an IPsec VPN, you would be limited to 1.25 Gbps. So those would be some of the considerations I would think about when thinking about spinning IPsec tunnels to each branch versus creating a head-end router and letting the branches connect to the head-end router over IPsec or any other tunneling protocol which is orchestrated by the vendor. And then with this aggregation point or the head-end router, you can create a connect attachment to your transit gateway or cloud WAN.
Yeah, just to also drill into that one too, think about it as scale. As in Kit was saying, you can have thousands of these SD-WAN sites, right? And if you do have thousands of SD-WAN sites, managing them and their routing propagations, seeing how they may not always be on all the time. If you were using a site-to-site VPN, you would start getting black hole routes if your other end started to die, or you get down tunnels, right? Depending on how that's happened. I've seen it where folks keep the tunnels up, but everything else is kind of offline. That can create quite a bit of headache on a network, especially when you're talking about thousands of sites. And then, not to mention, even if you're making any changes or any differences when your site comes up, if there's any differences in routing or any additions on every single site-to-site VPN, you're going to have to go and edit your routing tables, right, to make sure that everything can be seen. So that's where that comes in handy between the two. Another question. Yeah, no worries, Ganesh. Always happy to explain things for you. So, and for anybody else watching the show, please, if you need further explanations, there is no bad questions. For Highlandings, he has one question up here. He says, one thing that would be great is a way to tell the transit gateway to propagate routes to the VPC subnet route tables. Do you have any comments on that one?
Yeah. So um, yeah, that requirement comes up often, which is to automate the route tables of the VPCs themselves. Uh, um, What I see generally deployed with customers is some kind of a static route, either a default route or an RFC 1918 route that points to your transit gateway or cloud WAN. Now, that said, that's a very elegant mechanism if you have only one exit path out of the VPC, like here. There is nowhere else this VPC can go. Um, what you're saying would be super useful if, let's say, you had two transit gateways, or if this VPC had, a transit gateway, and let's say um, a private WEF that directly goes into a direct connect gateway, or basically multiple exit paths. That's where that requirement would come in very, very handy. I agree. There is some code that we have written. It's available on GitHub, and I'll find the link for that and put it in the chat. So as of today, that's a solution that's available, that you can download the code and work with, specifically with Cloud WAN. But overall, point heard that automating the propagation of VPC tables could also be beneficial.
Yeah. So basically taking that feedback, well, of course, we always go back to our service teams and let them know. But if this is something that you really, really need hirelings, you can certainly talk to your SA, ask for a PFR, all of that type of stuff, and get that to the attention of those making our products. Dominic has another question. Do we have public workshops available which covers SD-WAN GRE configurations like the one we're doing today? Are you aware of any workshops?
That's a good question. I'm not aware of them. That said, they might exist. That's an action on me. I'll check back and revert. Is so, Jamie. That's also an interesting one. How do we follow up on action items of a Twitch session?
So the best way we do it is, of course, try to come back. The chat will be open a little bit later,
Okay,
but also Dominic, you can reach out to me as well for those answers. He has a way of reaching out to me through one of our builder sessions, and joining builder communities is a really good way of getting direct access to us. We are, of course, working on mechanisms as well with the routingloop.net site to be able to basically transfer back and forth information, get the feedbacks from our viewers, and then also eventually one day sharing the decks.
got it, got it. So yes, that workshop thing I'll need to check. There might be something out there.
Yeah, I'll take a quick look as you go through the rest of your stuff.
Awesome. So we were debugging good old PGP. So show run interface tunnel 1 200.9 116.84 255.255.94. Last night when I was setting up router 1, after setting everything up, I realized my security groups weren't open. So that that also happens.
I always I liken the security groups these days to the cables. You know, like back in the day of the data center, is the cable actually pushed in all the way? Does the security group actually let you talk? You know, that kind
Yeah.
of thing. I'm trying to see. I have a solutions page for the SD-WAN solutions, but I'll dig a little bit deeper after the show and see about getting workshops available as well.
Six four five one two. That's what I did.
Are they getting you?
254 210 64512. Huh, this should work. So the demo gods, right, Jamie?
The demo demons, they're there.
Pierre closed the session. Interesting. This is one that I have never seen. Hmm. Okay, let me check one thing real quick here again. This is my Cisco CSR2. Pierre GRE 101.684. 101.684. 2010 and 11. It is exactly the same. Remote AS 64512 and 200 and just the neighbor statements.
And only, unfortunately, you have 5 minutes to figure this all out.
Brother, this suddenly feels like CCI lab from all those years back.
Oh, right, right.
6, 5, 4, 20. Okay. This shouldn't really matter. While I'm frantically debugging, Jamie, any other questions in the chat?
Everyone's just basically plus oneing that they like watching debugging sessions. This is typically how we all used to learn.
So, to be honest, I was planning to put in like an artificial mistake, which was a bad route table or something. Then I realized we won't have the time. And there we go. Artificial mistakes not needed, right?
Right.
Yeah, I have never seen this. The BR flag.
That's not a bad idea, Dominic. Dominic mentions that we can even plan a whole section or a slot for troubleshooting.
Let's do it.
Yeah.
It's
We
like
just
the
figure out
demo.
what we want to configure and just try to configure it and see what happens.
Yeah, yeah. The demo is ready already, Dominic. Yeah, this is interesting. I have routes. My tunnel interfaces are up. And it says peer closed connection. Huh. Maybe I just remove it and add it again.
Maybe.
Oh, there is something up with this. I'm not even the delete connect peer line is grayed out.
This isn't your beta account, is it?
It is not.
Okay. I made that mistake once, and I came to find out my account was actually just simply broken because I had done too many betas with it.
So peer GRE is mm, 169, 254, 200, 829, 654, 20. I didn't fat finger the
Trailing space? I don't think we allow for trailing spaces anyway.
654, 20. Yeah, yeah. Okay. Now let's see. We are pending and just the GRE address changes.
We're down to the last minute.
Oh, brother. Okay. Let's see. The IP addresses should be the same because 9, 10, and 11. Okay, they are the same. 65420, 65420, and 65420. Okay.
Well, unfortunately, we're going to have to end now because we are
Okay.
just a little bit over time. But we'll let you know real quickly if it popped up. And thank you all for joining. Thank you and Kit. We'll definitely have to do a part 2. I think we should just build something and see if we can break it and put it back together again. Maybe give Dominic and folks their troubleshooting session.
Yep, sounds good.
Fun. All right, everyone. Awesome. Thank you for joining, and we'll see you next week.
Thanks for joining, everyone. Apologies for the demo.
The demo's fine.